we casting? So over the next few minutes, we're going to walk you through a real-world. It's loading. Well, while that's loading, let me just say, so we're going to walk you through in the next few minutes a real-world example of a potential real-world example of what we face in a manned mission or crewed mission to Mars. So just imagine for a moment the oncoming storm. What's this? Nope, sorry. The oncoming storm. Right? So you have an information management system that's looking at your energy consumption needs and your energy production needs. So how do you make your decisions? How do you move from a catastrophe that could be happening to a solution? As a commander of your station, again, on a remote star. So here, this is the high seas systems monitoring system that's currently in use in Hawaii. And as you see, the system is pretty crude. The user interface doesn't give us a lot of interactive detail. It's just a splash page with some information. So what we want to do is propose a different way of organizing this information, and not only organizing information, but also providing a predictive model that allows us to make real mission critical decisions in real time, especially when that oncoming storm disconnects us from mission control, either temporarily or permanently. So we need to be able to make real-time use of our data on site. So we want to create a user-friendly interface that provides this information. It's clear and actionable, and we want to allow the system to be able to suggest and make different power consumption models based on previous, current, and forecasted conditions. So essentially the way Proxima works is that it feeds information from the current capacity of the solar panels, the battery generation, production, and it feeds all that into our AI, which then promotes and produces scenarios if a normal situation occurs. And then it executes it. It gives it to the commander or the staff, and it says, do this. So this is our basic dashboard. And again, this is an upgrade of the previous dashboard that's currently being used at high seas. So it gives us, again, the same kind of information, but in addition to that, it gives us future forecasted weather trends. It has the ability to, with a variety of sensor packages, we can actually see what the overcast situations are. And then we also get a snapshot of the overall power consumption and the available power, which is just essentially a metric of generated power plus produced power minus consumed power. And then we have a digital circuit breaker that is a breakout board from the previous screen that allows you to turn on and off individual experiments or equipment as needed. So again, here you go. You've got the consumption levels and the different scenarios that come up. The environment tab, which tells us what we are facing. So there's either satellite imagery or camera feeds. And then the system provides, based on an oncoming storm, it allows us to look at 3 different scenarios and gives us a way of stepping down. So it says we've selected option number 2 in the previous screen, and and it gives us step-by-step instructions on how to step down our systems. So Chris is going to walk us through how this will.
So in addition to providing tools to assist our scientists in other planets, we built a tool to help people back home understand their power consumption needs. We built this quick VR demo, and the environment adjusts to the simplified dashboard so that, for different times of the day.
I have a quick question while they're still exploring Mars. This is so beautiful, and definitely I'm not going to say anything comparing it because lots of good teams worked on the previous dashboard too, but this is beautiful. I was just curious, in comparison to that, did you add any, you highlighted some of the features like the step down for weather conditions and things like that. Did you maintain all the features that were already there on the dashboard? Were there any that you eliminated? Or
so we maintained all the previous inputs with the exception of the water tanks, which we forgot to put on there.
So-
But yeah.
So we adjusted it from ours, but our designer's computer stopped working. So I apologize for the precipitation there.
So as a data scientist, I squirm anytime I see like a deterministic forecast. So I'd just advise maybe consider using a probabilistic forecast for your dashboard where it says everything looks all right for the next 35 hours. I would just say, that for the next X number of hours, we're pretty sure, or X% sure that everything's, I think that kind of, gives you a confidence band. The other thing I'd say, are you guys familiar with SCADA at all? So SCADA is a power management software that's pretty commonly used in the U.S. right now. It's used in the military uses it a lot. It's used in a lot of places. SCADA has its limitations. The big one being UI. It's extremely complex and it gives you a ton of really granular data, but it doesn't really tell you any insights. So I'd love to see you guys. I think there's an expansion of this into kind of that same. Is not only giving you that like super granular and technical data, but gives someone an insight with it, so that there's not just the technical person that could think about this.
Yeah, so I guess like from our standpoint, we certainly see this as a set of different models. For instance, to forecast the future power consumption based on the previous experience, right? And also forecast the solar panels, which is the single source of energy. So we need to understand, how much energy we'll have like in 2 hours, what's the predicted consumption, and whether we have a balance. So this is one set of the, the models we need to build and train, right? The other, like the, big AI thing is that to do the decision support system. And like certainly we haven't built it because like we need to gather a lot of information right now, right? But this is doable. It's certainly doable, and there are some examples on the market where you can, have the similar cases depending on your previous experience, success rate, etc. So that's but like what we are showing is a prototype of the system.
I mean, also, and just to add to that, one of the snapshot features, because we realize that there's so much information coming into the station at any given moment that our goal was that if I walk by this panel or I pull it up, I can look at one metric. And right now, like the green bar that's right there is just our available power, which is in real time adjusted every day on current conditions. So at any given point, either Michigan or our power generation is down by 30%. We need to cut these things. So go to your lab and figure out what you need to cut.
Yeah. And so from a command and control standpoint, that's unless you have that super technical knowledge, it can be really difficult to make those decisions. So I love that you take it one step further. You're not just providing information, but you're providing recommendations rooted in historical data. I love it. I think that's a really smart way to go with this.
Yeah.
Oh, go ahead. No, please.
But I wanted to add also that this system is designed to Mars, but certainly some of these features can be applied to the real Earth conditions and use cases. Like the one thing, like the one type of the critical event we see is a dust storm coming. But like if you think of it, let's say in China, they have the smoke, and like if you have your solar panels, that will impact your the production rate of your solar energy. So something like this can be applied also to the Earth conditions.
Oh yeah.
I love that you tied it back to the Earth. I was just curious about the options that you provided for conditions. What was your planning process in terms of which processes should be stepped down? Like, was it based on, I might have missed this, like, was it based on information that HiSeas provided, or?
We looked at some of their press releases and some of their information down there online, and they outlined like mission critical components. So essentially like life support, HVAC, and then beyond that, we assume that perhaps like when you're you're running in a critical experiment, that if I've got biological samples that have to be maintained at temperature, I can assign that as a critical function. So that is excluded from the option sets for when the system says you need to step down 30% power, and these are the systems we suggest you step down.
I appreciate that. That's great. Yeah.
I just want to say I'm very glad that you guys created the Matt Damon rescue system. You don't have to worry about the dust storms clouding up the solar panels like in The Martian. So thank you for that.
He came up.
Yeah, we play squash. Yeah, I'm just kidding. But at the end of the day, like we have this. if you're on Mars, like, and NASA plans a long-term mission, they're gonna potentially have a, resupply drops and all these, like, anticipated, like, further exploration, right? So, but here on Earth, we don't have that resupply drop option. So for us, there is no resupply mission. So if we can port this solution from Mars or from high seas to China, to Saudi Arabia, to the United States, which are some of the largest per square foot of solar power production in the world right now, if we can get those solutions to them, we can maybe manage our systems a little bit better.